Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of Lewis structures. What is Lewis structures? Lewis structures are a way of drawing your elements, and if we're talking about elements and their valence electrons, okay, or in the case of more complex compounds, we look at their bonds and their lone pairs. All right. So it's pretty straightforward. If we have a straight line, that means we have two electrons represented. So this would be a single bond. For instance, this would be a double bond, and that would be 4 electrons. All right? 4. This would be 2. And then the triple bonds would be 6 electrons. All right, and lone pairs typically are going to be 2 dots. Sometimes you might see them as a straight line. And then single electrons, free radicals, or if we're dealing with elements, are going to be just a single dot. All right, what are the steps? Well, first with the elements, let's look at an element. Grab your periodic table. Let's look at fluorine. Fluorine's right there, and its valence is going to be 7 because it's a halogen. It's going to be on the 7th column or group. Here we have 1 electron. We start there, 2, 3, 4. Then we can start pairing up. That's basically it to the elements. There's not much to it. 2. And then that would be the Lewis structure for the elements. So start on each side, work your way around on what 1 dot on each side, and once each side has 1, then you can start pairing up. Okay, so 4 electrons times 2 is 8 possible valence electrons. All right, so if it's more complex than that, what do? Well, we first look at the periodic table, get the valence electrons for each element. Let's look at CH4, for instance. Where did I put my periodic table? It's probably behind here. Yeah, sure enough, it's right there. Let's go back to the table. And carbon has 4 valence electrons because it's in the 4th group. So we got 4. And then hydrogen has 1 valence electron. It's in the 1st group, but there's 4 of them total. So here we would have a total of 8 valence electrons. Okay. So let's move this back into the frame there. And as a result, if it was a plus sign or a minus sign, then we would subtract or add an electron. So for plus a number, say it was plus 2, that means we lost 2 electrons. Well, we then have to adjust for that, and our total we just found of 8, and we would have subtracted 2 from that 8. Okay, but if it's an anion, we gained 2 electrons, so we would need to add the 2 to that total number. All right. Then we draw the skeletal structure, putting the least, let's overemphasize that, the least electronegative element in the center. And once you have the least one in the center, you can start drawing your bonds. But sometimes symmetry will force you to put the most electronegative element in the center. Take this methane compound, for instance. Methane, the skeletal structure would look something like this. Because hydrogen can only form 1 bond, it has to be on the peripheral. Okay? Also, because of symmetry issues, we have to have these hydrogens out here. Okay? So whether it's restrictions on the number of bonds or symmetry, make sure you put the right element on the central atom. All right? So then we were going to add single bonds to complete octets. In our case, CH4 is pretty easy. We're done at this point, right? We can check the formal charges to make sure everything's kosher. So if you remember, you probably don't. It's been a while since you've looked at formal charge, or you might. You're a good student and you reviewed it before you watched this video. It's going to be your valence number of electrons minus the number of bonds plus lone pair electrons. Now it's the actual electrons. If it's just lone pairs, it's a little different, right? So in this case, for instance, the FC of the carbon would be 4, its valence is 4, minus, it's got 4 bonds, and there's no lone pairs on that one, okay? So 4 minus 4 is 0, it's neutral, and all the hydrogens have the same formal charges. It's going to be 1 minus the 1 bond plus the 0 lone pairs, which is also 0, okay? So test your formal charges, make sure everything makes sense. So if we look at this example here, bromomethane, carbon has 4 valence electrons plus 3 times 1 hydrogen valence electron. There's 3 of the hydrogens, plus the halogen of bromine is 7. So we have 7 plus 7 is 14 valence electrons. If we were to draw this, the least electronegative element is hydrogen, but since it can only form 1 bond, it has to be peripheral. And bromine being a halogen has to be on the outside. So therefore carbon's left as the central atom, and then we put 3 hydrogens on the outside. Then there's your bromine. So here's the single bond step. Add your single bonds. 2, 4, 6, 8. So we would take 14 minus 8 to give us 6 lone pair electrons. We would do 2, 4, 6, 8. 2, 4, 6. This is definitely my last video. Okay, so basically what you're going to do is you're going to end up matching. The formal charge would be 4 minus 4 bonds, no lone pair electrons, so that'd be 0. Halogen would be 7 valence electrons minus 1 plus 6 lone pair electrons is 0, and we've already done the hydrogen before. Okay, so if that doesn't work, sometimes you have to add double bonds to make it work, like for formaldehyde, for instance, which is CHHO. That would be a valence of 4 plus 6 is 10, 12 electrons. So if we add 1 for each of those and 1 there, right away you can see that carbon doesn't have this octet. It's not valid, so we didn't need to put a double bond there to make it right. Then at that point we have 2, 4, 6, 8 minus your 12. 12 minus 8 gives you the 4 lone pairs, and guess what oxygen needs to give it a complete octet? 4 electrons. And if you were to do the formal charges here for that one, you would see that it does have a neutral net charge. Okay, so you might get multiple valid Lewis structures. The one that has the most bonds with the fewest number of formal charges is your winner. Okay, so again, if there are multiple choices, what you want to do is you want to pick the one with the most bonds and the fewest number of charges. So I hope I've clarified any doubts that you might have over Lewis structures with the concept. I have given you a few basic examples, but believe me, they'll get a lot more complex than that. So make sure you check out the example videos, and most of all, practice, practice, practice. Thank you and have a nice day.